So this video will cover the multiple choice questions from the IR Part 337 assignment from class. So the first question, which of the following best explains why a carbon-hydrogen bond in an sp2 hybridized carbon absorbs at a higher frequency than in an sp3 hybridized carbon? So first, let's look at what an sp2 versus an sp3 carbon is, just as a review. So this is our sp2 carbon right here, and then here we'll have sp3. So this bond between the sp2 carbons is a double bond, so that makes it shorter and stronger. And this one is a single bond, so it's longer and weaker. So we know from Hooke's law that frequency is based on a spring constant and mass. So the shorter, stronger bond will have a bigger spring constant than the single bond, which will give us a higher frequency. So looking at our answer choices, we know that the sp2 carbon wouldn't have a larger mass because it's still just a regular carbon. So that rules out A. And then for B, the sp2 carbon has a shorter, stronger bond. So that's what I was talking about before with Hooke's law. Just crossing out the rest of the answers, it would have a lower spring constant, so C is wrong. And D is kind of saying the same thing. And then sp3 has a shorter, weaker bond, which is not true. It would be a longer, weaker bond. So for number 2, according to Hooke's law, what effect does increasing the spring constant K have on the frequency of a spring's oscillation? So as I said before, Hooke's law is frequency equals the root of the spring constant over the mass. So if you increase K, you'll be directly increasing frequency. So B increases frequency. Moving on to number 3, what characteristic is indicative of an alcohol in an IR spectrum? So for an alcohol, you would expect something like that before 3000. So looking at our answer choices, B, a broad, intense peak in the 3000 range. So for number 4, what causes the nitrogen-hydrogen stretch in amides to be less intense compared to OH stretches? So this has to do with the electronegativity of nitrogen compared to oxygen. So oxygen is more electronegative, so it pulls the electrons stronger than nitrogen would. So that means that the nitrogen-hydrogen bonds are less polar compared to the oxygen-hydrogen ones. And that makes their hydrogen bonding weaker because there's less of a pull. So that lines up with option C. So number 5, what effect does conjugation have on the frequency of the carbonyl stretch in a molecule? So conjugation looks like this. So there are those two double bonds with a single bond in between. So what this does is this slightly reduces the wave number. And then how I remember how it relates to frequency is that I remember wave number and wavelength are inverse, and wavelength and frequency also have an inverse relationship. So two inverses kind of cancel out. So that shows you that wave number and frequency are a direct relationship. So because conjugation slightly lowers wave number, it also slightly lowers the frequency. So that would be C. So for number 6, what type of bond stretch is indicated by a sharp peak in the IR spectrum and is typically associated with alkynes and nitriles? So alkynes, you have this C triple bonded to another C, and then nitriles, you have a carbon triple bonded to a nitrogen. So for both of these, they present pretty much like a carbon-carbon triple bond stretch. And that's because the nitrogen is close enough in mass to the carbon that it appears around the same wave number. So the answer to this one would be B. And then for number 7, which of the following statements is true about the intensity of nitrile stretches compared to alkyne stretches in an IR spectrum? So because the carbon-nitrogen bond is more polar, it tends to be more intense on the IR spectra. So that would be the end of the multiple choice section. I'll post a second video with the first 3 free response questions.